Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0706 indicates an issue with the transmission range switch within the Honda Civic models from 2011 to 2015. This switch is vital for relaying the appropriate gear shift position of the vehicle's automatic transmission system. Essentially, it helps the powertrain control module, PCM, understand which gear the vehicle is in during operation. Located on the transmission housing, this component interacts with the shift lever, ensuring that the vehicle can engage safely in different driving modes like park, reverse, or drive. The P0706 code arises from an electrical circuit failure, which does not stem from mechanical transmission issues. Understanding this code is crucial as it impacts the vehicle's ability to shift gears correctly and could lead to performance problems or even safety hazards if left unresolved. The transmission range switch serves as a reliable communicator between the shift lever and the powertrain control module, PCM. This essential component is mounted on the transmission housing of the Honda Civic and is responsible for relaying the selected gear position, whether it's park, reverse, neutral, drive, sport, or low. The proper functioning of this switch is crucial for the PCM to execute commands to the engine and transmission control module, TCM, based on the vehicle's current gear. If the switch fails, the PCM may not receive accurate information on the vehicle's readiness for a certain driving condition, which not only affects performance, but may also engage safety protocols to prevent possible malfunctions. Incorrect readings can lead to erratic shifting behaviors, diminished fuel efficiency, and even engine stalling in extreme cases. Recognizing the position of this switch and its function is vital for proper diagnosis and repair. The P0706 error code is primarily triggered by issues within the electrical circuitry, rather than mechanical problems within the transmission itself. A misaligned shift cable can lead to erroneous readings sent to the PCM from the transmission range switch, which may result in a failure for the computer to ascertain the accurate position of the gear. Additionally, damaged or corroded connectors and wiring can disrupt signal transmission, resulting in improper functioning of the switch. It's crucial to ensure that all wires and connectors are intact and free from wear. Poor grounding can also inhibit the effective flow of electricity, causing the system to register false signals. Understanding these potential causes is the first step in resolving the issue effectively. When the P0706 code is present, drivers may observe multiple symptoms indicating a problem. An immediate signal is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue. Erratic or unpredictable shifting behavior is another common symptom, as the vehicle may shift gears at inappropriate times or may not shift at all. Some drivers may experience their transmission getting stuck in a particular gear, rendering the vehicle difficult to drive or control. Additionally, reduced engine performance and fuel efficiency might be noticeable, as the PCM is unable to optimize the engine's performance without accurate gear data. Addressing these symptoms promptly can prevent more severe transmission damage or performance issues down the line. The initial troubleshooting step involves verifying the adjustment of the shift cable. A misadjusted shift cable may lead to faulty readings from the transmission range switch, triggering the DTC P0706. Start by ensuring that the cable is correctly aligned, allowing for smooth operation of the gear lever. Following this, turn the ignition switch to the on mode to power the vehicle's electrical systems. Once powered, it is crucial to compare the transmission range switch signal inputs against the specified table using the Honda Diagnostics System, HDS. Observing the status of each switch based on the gear position selected will help confirm if the signals are being transmitted correctly to the PCM. Identifying if these signals are okay or if inconsistencies occur, will determine whether to proceed to further diagnostic steps. In this step, it's essential to perform a thorough check on the transmission range switch signals again with the HDS. This involves comparing current signals to those listed in the reference table for each gear position. If all transmission range switch signals indicate off when they should not, it may suggest an issue. If any signal does not match expected readings, you should document which circuit is behaving abnormally for further investigation. This observation is critical for understanding whether the fault lies within the switch itself or within the wiring or connectors feeding to the switch. Gathering this data will aid in efficiently isolating the source of the problem as you proceed to the next steps. Moving on to step 3, it is important to turn the ignition switch to lock or off mode to ensure safety while working on the electrical components. After that, you should disconnect the transmission range switch 10P connector, which houses critical wires related to the switch signaling. Following this, a jumper wire should be used to connect terminals A and B on the connector to test the circuit's functionality. Terminal A should connect to the corresponding circuit that did not indicate on in the previous step, while terminal B connects to the body ground. By doing this, you'll simulate a proper connection and check if the switch signals the PCM correctly once the ignition is turned to on mode. If the intended signal indicates on as expected, it suggests that the switch itself might need replacing. In troubleshooting step 4, the focus shifts to conducting open wire checks to ensure there are no breaks in the wiring that could cause erroneous signals. Ensure the ignition switch is turned to lock or off mode for safety. Then, as a preliminary step, the SCS line should be jumped with the HDS for optimal diagnostics. Next, the transmission range switch 10P connector and the PCM connector B should be disconnected. Continuity will be checked between the test points and the body ground to confirm the integrity of the wiring. This test is crucial because even a small break in the wire can lead to significant issues in signal transmission to the PCM. If there is continuity, further steps involving updating or substituting the PCM may be needed. If not, you will need to locate and repair the open wire. In the final troubleshooting step, the procedure involves checking for an open wire on the power ground PG line. As always, begin by turning the ignition switch to the lock or off mode to ensure safety throughout the testing process. Remove the 10P connector again for a more focused inspection. The next move is to check continuity between designated test points, particularly between point 1 on the transmission range switch, 10P connector, and body ground. This test verifies if the PG wire has an uninterrupted pathway, which is crucial for the switch's correct functioning. An affirmative result confirms that the PG wire is fine. However, should you encounter issues, it indicates the need to repair an open in the wiring to maintain a secure ground, ensuring reliable signal transmission. Once all repairs are completed, it's crucial to conduct a thorough, final verification of the repairs done. Start by rechecking all connections to ensure that everything is securely fastened and that there are no loose wiring or issues with connectors. Following this inspection, a test drive of the vehicle is essential to see how it operates under normal conditions. Monitor the behavior of the transmission during this drive. Ensure that shifting is smooth and that no warning lights illuminate on the dashboard. It's also beneficial to use HDS to check for any remaining DTCs to confirm that the P0706 code has not returned. This thorough approach is vital to ensure the long-term reliability of the repairs before concluding the procedure. To prevent future occurrences of the DTC P0706, implementing continuous preventive maintenance is crucial. Regular inspections of wiring and connectors can help detect wear and tear before they develop into larger issues. Look for any signs of corrosion, especially at connection points that may lead to signal loss or faulty readings. Additionally, ensure that the shift cable stays correctly adjusted. Regular checking can help prevent misinterpretations of gear positions, which directly relate to the functionality of the transmission range switch. Keeping your vehicle's electrical systems clean and free from debris is also an integral part of ongoing maintenance, contributing to the long-term performance of the transmission system. Following these steps can greatly increase the lifespan of the components involved, ensuring a smoother driving experience. In conclusion, understanding and effectively addressing the DTC P0706 error code is vital to maintaining the health and performance of the Honda Civic models from 2011 to 2015. Recognizing the symptoms that accompany this fault allows for prompt action to prevent further complications. The provided troubleshooting steps offer a logical sequence to accurately diagnose and repair the underlying issues within the transmission range switch circuitry. Lastly, embracing preventive maintenance practices will proactively safeguard the vehicle against future problems associated with this code, allowing for a reliable driving experience. By adhering to these guidelines, drivers can ensure their Honda Civic remains in optimal condition, securing both performance and safety on the road. Please like and subscribe to the channel. See you next time!